Hello, in this session, I am explaining working of single-phase semi-controlled AC to DC converter connected to R load. AC to DC converter is also called as a rectifier. So what is a rectifier? A rectifier converts sinusoidal AC voltage source into a DC voltage supply by means of diodes, thyristors, transistors. This rectifying process can take on many forms with half wave, full wave, uncontrolled, semi-controlled, and fully controlled rectifiers. These rectifiers are transforming a single phase or three-phase supply into a constant DC level. So what are the applications of rectifier? Rectifier is used in flexible speed industrial drives. It is used in battery charger, high voltage DC transmission system, uninterruptible power supply system. In this session, I am explaining working of semi-controlled converter connected to R load. So what is a semi-controlled converter? A semi-controlled converter consists of the controlled power electronic devices as well as uncontrolled power electronic devices. So this figure is indicating a bridge rectifier. This bridge rectifier consists of 4 semiconductor devices. Out of these 4 semiconductor devices, 2 devices are control switches and 2 devices are uncontrolled switches. So this semi-controlled converter consists of 2 thyristors and 2 diodes. Now depending upon how these thyristors and diodes are connected in a bridge rectifier, the semi-controlled converter is classified as symmetrical semi-controlled converter and asymmetrical semi-controlled converter. In case of symmetrical semi-controlled converter, each arm of a bridge rectifier consists of one control switch and one uncontrolled switch. Also, the cathode of 2 thyristors in a bridge rectifier are connected to same potential. So we can connect the gate terminal of these 2 thyristors together and we can use a single triggering circuit to apply a triggering pulse to these thyristors. Whichever thyristor is operating in forward bias condition will get turned on. So this is called as symmetrical semi-controlled converter. In asymmetrical semi-controlled converter, one arm of a bridge rectifier consists of control switches and second arm of a bridge rectifier consists of uncontrolled switches. The cathode of thyristors, which are acting as a control switches, are connected to different potentials, and hence in asymmetrical converter we need two separate triggering circuits to provide triggering pulse to these thyristors. If we see the construction of these two arms, then these are not symmetrical. Hence, it is called as asymmetrical semi-controlled converter. In today's session, we are studying working of symmetrical configuration, or we are studying working of symmetrical semi-controlled converter connected to R load. A circuit diagram of symmetrical semi-controlled converter is shown here. The input supply connected is a AC supply, and at the output terminals of a converter a resistive load is connected. The input voltage waveforms, output voltage waveforms, triggering pulses applied to the thyristors, and the waveforms of load current are shown here. Now let us study how this converter is converting AC voltage or AC supply into a DC output supply. Now let us consider that at omega t equal to 0, a positive half cycle of the input source will get connected to the rectifier. So when this positive half cycle of a voltage will get applied, then this thyristor T1 will get forward bias and diode D1 will get forward bias and diode D1 will get forward bias. Now at instant omega t equal to 0, no triggering pulse will be applied to thyristor T1. Triggering pulse is applied at an angle alpha to thyristor T1. So from instant omega t equal to 0 to instant omega t equal to alpha, this thyristor T1 acts like an open switch, and hence there will be no connection between the load and the source, and hence no current will be flowing from source towards load and no voltage will be applied to the load. So if we observe here, then during this particular time period, output voltage will be 0 and output current is also 0. At instant alpha, triggering pulse is applied to T1. So with this, T1 starts conducting and load will get connected to source through T1 and D1. So with this, current starts flowing from source through T1 or D1 back towards the source terminal. So the direction of the load current is shown here. This direction of a load current is considered to be positive, and the voltage appearing across the load is considered to be the positive voltage. So from instant omega t equal to alpha to instant pi, positive voltage will appear across the load and positive current starts flowing through the load. At instant pi, the source current and source voltage will get reduced to 0. So a natural commutation takes place in thyristor T1 and T1 will get commutated. From instant omega t equal to pi to instant omega t equal to 2 pi, a reverse voltage starts appearing across this bridge rectifier. So for this reverse voltage, thyristor T2 will get forward bias and diode D2 will get forward bias. But from instant omega t equal to pi to instant omega t equal to pi plus alpha, no triggering pulse is provided to T2. Hence T2 is acting like an open switch and there will not be any connection between the load and the source. Hence no current is flowing from the load and no voltage is appearing across the load. At instant omega t equal to pi plus alpha, triggering pulse is applied to T2. With this, T2 will get turned on and load will get connected to source through T2 and diode D2. Hence, the current starts flowing from N terminal of the source through T2, resistance R, T2 back towards L terminal of a source. So again, during this particular operation, the load current flowing through the resistive load is positive and voltage appearing across the load is again positive voltage. So this positive voltage is shown here by the shaded waveform and the positive current is shown here. Again at instant 2 pi, the source voltage and source current will get reduced to 0 and natural commutation will take place in thyristor T2 and T2 will get turned off. So during this operation, what we are observing that when a positive source voltage is applied to a rectifier, then the output voltage is positive as well as output current is also positive. And when negative voltage is applied to the rectifier, then also the output voltage is positive and current flowing through load is also positive. Thus, a rectifier is converting AC voltage or AC supply to DC supply. So in this way, a semi-controlled converter is converting AC power supply to a DC supply. So this is working of a semi-controlled converter connected in symmetrical configuration. So now let us see the equations for average value of load voltage and load current and RMS value of load voltage. Now if we observe the waveform, then we are getting output voltage in during each of the half cycle. We are getting output voltage during positive half cycle of a source voltage as well as during negative half cycle of a source voltage. So when we find average output voltage, then it is given as V0 is equal to 1 upon pi integration from alpha to pi Vm sine of omega t d omega t. When we solve this equation, we are getting the equation for output voltage V0 as Vm upon pi 1 plus cos alpha. So what we are observing here that the output voltage, it is proportional to the firing angle alpha. So as we vary firing angle alpha, so with the variations in the firing angle alpha, output voltage V0 will also get varied. And in this way, we are getting a variable DC output voltage as well as a variable DC output current. In this case, as we have connected a resistive load, so the average load current is given as I0 is equal to V0 upon R. So we can write the equation for average load current as I0 is equal to Vm upon pi R into 1 plus cos alpha. Similarly, we can find the RMS value of load voltage. So RMS value of a load voltage is given as VL is equal to square root of 1 upon pi integration from alpha to pi Vm sine omega t square t omega t. And when we solve this equation, we are getting the equation for RMS value of load voltage as VL is equal to Vm upon root 2 into square root of 1 upon pi minus alpha plus sine 2 alpha upon 2. In this equation, Vm upon root 2 is Vs. So we can replace this with Vs and we'll write the equation for RMS value of load voltage as VL is equal to Vs square root of 1 upon pi minus alpha plus sine of 2 alpha upon 2. So this is about the equation of average value of load voltage, average load current, and RMS value of load voltage. So this is all about the working of semi-controlled converter connected to R load. Thank you.